This calculation comes from our textbook. It is example 2.3. Now before I jump into the example, I just wanted to show you the formula that we use for torque. It's also important to note that it is actually the armature core that produces the torque. That's the main function of the armature core. And if you take one slice of the armature core, it will give you the diagram with a number of possible slots. So to calculate torque, it is 0.318 multiplied by IA times the flux times small letter p times Z over C. IA is the armature current in amperes, the flux measured in Weber, small letter p is the number of pole pairs, Z is the total number of armature conductors, C is the number of parallel paths. If it's wave wound, C is equal to 2. If it's lap wound, C is equal to 2 times the number of pole pairs. Okay, so this question, a 6-pole DC motor has a lap wound armature with 10 conductors per slot. The motor develops a torque of 110 Newton meters when 36 amps flows through its armature. For a useful flux per pole of 0.025 Weber, calculate the number of armature slots. So here's one slice of the armature core with a certain number of slots, and we have to work out basically the number of slots if we are given the number of conductors per slot. So let's first start off by writing down the information that is given. So it is a 6-pole DC motor, so therefore there are 3 pairs. It is lap wound, so therefore C is equal to 2 times the number of pole pairs. 2 times 3 will give us 6 parallel paths. There are 10 conductors per slot, so Z will be equal to the slots multiplied by 10 conductors per slot. The motor develops a torque of 110 Newton meters, and the armature current is 36 amperes. The useful flux per pole is 0.025 Weber, and we need to calculate the number of armature slots. Okay, so to do that, we need to work out Z, and I'm going to use the torque formula because torque is given to us. Let me just show you the torque formula. 0.318 times IA times Z times P times flux, okay, all over C. So we need to solve for Z first. Right, so if we manipulate the equation to get Z on its own, it'll be the torque multiplied by the number of parallel paths all over 0.318 times the armature current times the flux times the pole pairs. So if we let's substitute everything in here, we have 110 Newton meters. It is lap wound, so the number of parallel paths, 2 times 3 will give us 6 over 0.318 times 36. And the useful flux per pole is 0.025, and the number of pole pairs is 3. So therefore, the total number of armature conductors will be 768,693. Now remember, they asked us for the number of slots. So to do that, we will say the total number divided by the number of conductors per slot, which was 10. So 768,693 divided by 10 gives us 76,869. Right, that's it. Thanks, guys.